Let's make a Windytron. Jumbo. So, yeah. Just printed this case out in wood fiber PLA. Here's our Max 7219 8x64 LED module. First thing we do, guys, gotta chop this 90-degree header off because it ain't gonna fit. So the way we do that is you gotta like pop this one module off and then desolder here and pull the header out. We're gonna access the header from the back, not the side. So yeah. Soldering iron on. Let's get our little vise here. How do I like to do this? Chop and drop. Yeah, these are really bad. Close your eyes. Close your eyes. Now I can get the spacer dealy guys off. Now I can solder. Uh-oh, I got my pointy tip on. Alright, let's try it. Okay, I'll try it without. Boom. Come on. Boom. Boom. Okay. Match up the sides here. Now there are two classes of this module board. There's the ones that are one continuous board, and the spacing is a little bit not quite as good. Yeah, you can see it's sort of designed from multiple modules. There's the brake line, and you can see the fitment is better. Overall width here is 128, whereas this one is 131. You can see that difference there. So when you're printing your enclosure, you got to know which module you got. It's kind of a crapshoot which one you get from the Amazon. Gonna get some of this silicone wire. As you can see, we got 5 pins, and the only one that needs to be on this side is the D in, because the data in gets shifted to each module in order. But all the other pins are basically attached through. So what I do is attach the data in here, and then I can do 1, 2, 3, 4 on the other ones. Makes a nice little swoopty connect. do like about that long, make sure it reaches. But we only need 5. So take one off. Save that for later. Hands. Okay. So it can be like a, usually keep the white for power. And then I made this nifty little SPI. This is an SPI interface, so you see how these match up, kind of. So, and they go to the right pins, so I don't have to worry about soldering in a specific pin order. Although soldering this onto the board is more work than figuring out which pins to solder to. So, what goes to D in there, the rest can go there. Let's just tin up our other pins real quick. Get the clock. The chip select. Ground. VCC. That's power. Look at that big old blubber. Take you out of here. Okay. Now we got a strip. Let's try to do like 2 at a time. Thumbnail. You just gotta tin them up. That's how you solder, folks. Tin, join. Tin one side, tin the other side, and then join them together. Oh, there's a big glove on that guy. Alright, let's do our data first. Some people like to put it through the hole, but it's kind of a hit or miss proposition sometimes. Overheat the pad, cause problems that don't really want to do. Power. Ground. Now we'll do the chip select. Now we'll do the clock. See, kind of cute. You can glue that for some strain relief. And then it's like, so then that can go to the daughter little adapter, and then control board is going to sit right here. USB port here, main switch there. And use a little display supports, so when you put it in there, let's see, Windytron. Oh. Can you see in there? Oh. So here's the original one I did with green. It goes on like this. And then here's your SPI header. But all these pins soldering, it's like, is it worth it? I'm not sure. But it's kind of cool to have enable, switch, battery connector, because you kind of run out of grounds and stuff on here. A quick tip, if you're not using the battery wire closest to the USB port is ground, so you can, like, if you need ground, you can go ground. You could even solder to the top of here, but then you make it solder up in there. Or you can actually usually rip this battery connector off, since I don't use that connector, and solder directly to the battery pins. So then this guy goes here. A little bit of extra space there for other boards that are wider. But you just glue that guy in. And you put the little power switch here. Displays in there. The back is printing currently. You got yourself a Windytron Jumbo. So let's actually see if the depth of these are different. Got 13.23 millimeters versus the other module. Oh wow. 11.27. So if that was to go in there, then how flush would it be? It would almost be too... Man, I need to make an extra parameter in my model for the depth of these modules. Very different. Wow. Let's see. What is that? Okay, let's do some header stuff. These are headers. Go like boom, boom. Okay, 3 volts. Ground. Battery. Oh, seems a little bit not in there all the way. Going to do a quick squeeze and join. Okay, got battery. EN. ACK is 5. Just get this guy again real quick. Did that pop out? Oh, not too bad. So then I need 22. Oh shit. This board wasn't designed for the ESP32, it was designed for the ESP8266. Alright, so instead of that, standard MOSI, master out, slave in clock I guess I'll just not use this header because they're going to the wrong pins. We will, but I do need to solder these two guys. So we'll just tap these wires instead of the header. I'll go into one of these, two of these. This is why having fingernails is good. Even short bit off ones. This is why I love silicone insulated wires. Tin it up. Tin it up. Oh, whoa, whoa. Always use new, fresh solder when tinning. Don't be afraid to use a lot of it.
Turn these down to a reasonable length.
Okay, let's tin up these guys here. Got power, just 3 volts. Ground. That's the chip select. I bet it's totally like bubbling in the bottom there. I like to put some on there and then lift up, make a little bulb, a little globe. I mean, it's kind of neater. Guess it's kind of cool. Might as well tin these guys up. So now if I was going to hook up a battery, ground and positive, there's a blank board, so ground and positive goes to battery pin right there. Normally you glue the battery like 18650 right here, and then switchy, power switchy. And depending on if you're using a battery or not, you can use this as a battery cutoff, or you can go to the EN and just have the board turn on or off. And if you wanted both, then you would print an extra little cutout here and an extra button would go in there. Oh look, there's a little button stand. I accidentally printed it and now it won't fit, but because I'm not actually using the enable button there, I can chop that off and carefully chop it so it doesn't break anything. Hopefully that'll work. Oh no, now it's hitting that one. Shoe goo, goop, the best glue. I usually have a little tube to do this with, but good. You really don't need that much glue, just a little bit of hold it on there. When it glue's good, it just dries up and peels off. Okay.
Okay. Now I just like to put a weight on it and let it dry. Kind of puffed up some. Okay. See you in a bit.
Okay. Battery soldered in. Sorry, I didn't show you that. And just pop this guy in there. Typically the O means off, dash means on, but in this case, when you short the enable pin, it's off. So turn it the other way, so up is on. Okay. Glue that guy in. Solder this guy there. Program with the special Windytron firmware. And it's good to go. Let's see if it flashes though. Sometimes it'll flash on. Nope. Let's check and see that we got the proper voltage. Should have VCC and ground. 3.2 volts. It's a 5 volt LED, but it runs on 3 volts fine, so. Alright, let's go program this thing. Okay, we got the guy all in there. Got some glue. Plug them in there. And then we just need a little bit of tape. Hold them in place while the glue dries. Don't need much. Oh, the tape came off. Damn it. Oh, it's upside down. Oh yeah. So just gotta set that to upside down equals true. And we're all good. Okay, now we just gotta solder on the power. So chin these guys up and join them. Tinned. Tinned. Here's the back I printed. Slightly different shade because I ran out of filament. Well, okay, and then when that glue dries, we're done.